Hello everybody, so today we will be entering our last chapter, which is on kinetic theory of gases and thermodynamics. So I think there are four subtopics, if I'm not mistaken. There probably is four. Oh, sorry, there are five subtopics in this chapter. So this is quite a long chapter because this is actually a combination of two chapters from the previous syllabus lah. Okay, so let's look on to the first chapter, which is, sorry, not chapter, the first subtopic, which is on kinetic theory of gases. So for this subtopic, you have to be able to state the assumptions of kinetic theory of gases, describe RMS speed of gas molecules, and solve problems related to the RMS speed and any problems related to the equations yang you will be learning in this subtopic lah, okay? So there are four variables that we use in order to describe gases. First one is N, which is the amount of gas. N is equal to M over capital M, which is the molar mass of the gas lah. Alright. Next we have pressure. So it is the force per unit area of a gas particles which exert on the wall of their containers. So 1 atmospheric pressure is equal to 1.013 times 10 to the power of 5 Pascal. Okay, so this is important for unit conversion lah. Next we have volume, where the gas volume should be similar to the volume of the container lah. So 1 liter is equal to 1 times 10 to the power of negative 3 cubic meter. So this is their SI unit lah, both of this. Temperature on the other hand is usually measured in degrees Celsius, but now we need to change into Kelvin. Okay, so for this topic, for this chapter, kamu perlu convert dia pergi Kelvin, not in degrees Celsius. So how do we convert degrees Celsius to Kelvin? Is we are just gonna plus it with 273.15 in order to convert their pergi Kelvin. So that is the four variables used to describe gases. Now we have an equation for ideal gas. So in general, for a fixed quantity of gas with mole N, it will occupy a volume of V at pressure P and absolute temperature T. Okay, so sekarang ni kita ada satu equation yang relate this to the ideal gas, which is PV equal to nRT. Okay, so P is pressure, V is volume, N is the number of moles, R is the molar gas constant, T is our absolute temperature. Remember, it needs to be in Kelvin. Okay, so this is just the equation. So this is basically what's happening in this equation. Kalau kita look based on the diagram, apa yang present. Okay. So the number of moles can also be expressed as N equal to capital N over the Avogadro constant. So capital N is the number of gas molecules. Small n is number of mole. Okay, they are not the same. So Avogadro constant is 6.02 times 10 to the power of 23 per mole. So yeah, N is equal to this and also this one. So the ideal gas equation from PV equal to nRT, it can also be written as this equation here. So after you substitute there, kamu akan dapat PV equal to NKT. So K ni apa pula? K is our Boltzmann's constant. Boltzmann constant ni kita dapat dari molar gas constant divide by the Avogadro constant. So dapatlah this value here. So it is given in your formula sheet. So it's not really a problem for you. Kalau dapat ingat, it saves time lah bila kamu solve questions di exam nanti. So this is basically the ideal gas law in terms of molecules. This one here is in terms of mole. This one is in terms of molecules, number of molecules. Okay, so why do we learn about kinetic theory of gases? So basically it would relate the macroscopic property of gases, which is the pressure, temperature, volume, internal energy, to the microscopic property of gases, which is the motion of atoms. So we are relating this here to the speed of the molecules ataupun atoms ataupun the momentum of the molecules. Right? So that is why they have a kinetic theory of gases. So what are the assumptions of this kinetic theory of gases? There are 6 of them, and basically in exam they expect you to remember what is the assumptions lah. Because sometimes the question would relate to these assumptions, and then in UPS I believe, oh, that's why UPS 7 and 8 UPS, so that adalah UPS. Okay, but these are the assumptions of the kinetic theory of gases. So basically the first assumption is all gases are made up of identical atoms ataupun molecules. It is moving constantly and randomly with each other and the walls of the container. So because they keep on moving, there are collisions, and the collisions are perfectly elastic collision. The volume is negligible when compared with the volume occupied by the gas. Intermolecular forces are negligible except during collision. So there is basically no interaction or attraction, repulsion between the atoms or molecules. Oh, I forgot to add something. Close bracket. Next, the duration of the collision is negligible in comparison with the time spent traveling between the collisions. So these are 6 of the assumptions lah. Next, why do we take RMS speed? Why don't we take the normal speed? Okay, kan kita ada belajar speed di chapter 1 and 2. So why don't we use that for atoms? Why do we need to use RMS speed? So for gas molecules, since it is constantly moving in random motion, each individual particles will move at different speed. So they are constantly colliding and changing directions. So this RMS speed is used to describe the movement of the gas molecules, okay, considering both speed and its direction. Okay, so the gas molecules that would be moving in the opposite directions will have opposite signs. Remember, velocity kita ada positive and negative. So kalau dua-dua ni move in the opposite direction, they would have a different sign lah. Okay, so the velocities of these gas molecules are positive and negative by assuming that all particles are moving equally in different directions. So, bila kita buat average velocity, kita akan dapat 0 sebab sebab kita punya positive and negative ni. Okay? So, kalau kita dapat 0, it wouldn't be helpful. So, apa yang kita buat, apa yang they suggest to do is we have to square the number dulu. Kenapa kita mau square? Sebab dia mau bagi positive velocity. Okay? So, bila kita dapat positive velocity, kita boleh take the root of the square of the average velocity, which will give the average speed, but without the direction. Kita tidak akan dapat direction sebab kita sudah square dia. Okay? So, kita akan dapat positive velocity sahaja. So, kita just akan dapat the magnitude of the velocity. Okay? So, dapatlah kita this equation here. Right? So, that is why we use RMS speed lah. Root mean square speed of gas molecules is a measure. It is a measure of the speed of molecules in a gas. Okay, so it is defined as the square root of the average velocity squared of the molecules in a gas. So this is the equation. Okay, so it depends on how many velocities there are lah. Kalau ada 3 aja lah. Kalau ada 8, tambah lagi lah sampai 8 tu. Okay, right. So to compute this RMS speed, we have to square each molecular speed and then divide by the number of molecules and then take the square root lah. Macam kita cari average gitulah. Okay? Okay, so that is on RMS speed. Now, on pressure of gases, according to the kinetic theory of gases, gas pressure is the result of collisions of large number of molecules on the wall of the container. So, kenapa ada pressure of gases? Sebab yang atoms sekarang ni, dia balik-balik collide with the wall of these containers, which create a gas pressure. Okay, so as it collides with the wall of its container, it will change direction. Okay, so bila kita langgar di sini, tak akanlah kita tembus sampai sini kan? Tak kan? So dia akan change direction. So when they change direction, it causes the particle to exert force on the wall of the container. So this is on chapter 3. Kalau objek tu langgar macam ni, instead of dia terus pergi kanan, dia akan bergerak pergi kiri. So there is a force that is happening between the wall and the what do we call that, object lah, ataupun sekarang ni kita consider pasal atom. So the force exerted over a unit area by all the molecules is known as pressure. So pressure is equal to force over area. So what is the relationship of this pressure with the root mean square speed? Is this one here. Okay, so this is the relationship. So let this equal to equation 1. Let this as equation 1. P, that's turun V, P sebelah je. So we know that the density of gas is equal to mass over volume. So Nm over V. So when we substitute this into here, we will then get an equation of this. So this relates the macro. I don't know how to pronounce that. Macroscopic. I don't know, but macroscopic. Basically, it relates pressure to the RMS speed lah. So this is the relationship between pressure and RMS speed. Kalau ada soalan tanya tu, kita guna yang equation yang di sini. Okay? Okay, so now let's relate this RMS speed with temperature. So from the ideal gas equation, we have PV equal to NKT. So bila we compare it with the equation of PV equal to this equation here, we can let PV equal to NKT. Okay, so bila kita combine these two here, we will then get an equation like this. But we need it to be RMS speed saja. So kita pindahlah square tu pergi sebelah. So we get an equation like this. So this is basically, telling us about the relationship of RMS speed with temperature. Okay, so tadi tu kita belajar pasal RMS speed and pressure, but this is also the same thing. So it depends on what information is available lah. So kamu boleh choose to use this ataupun this one. Okay, and then instead of just 3 kT over the mass of gas, we can also use 3 RT over the molar mass of the gas. Okay, so this is also an equation that you can use lah. So sekarang ni kamu ada dua equation that relates RMS speed with temperature. Okay, macam tu lah. Alright, so this is the definition of each. This is what each variable is, and then this equation indicates that the RMS speed is directly proportional to the surd of temperature. So kiranya kita boleh letak VRMS is directly proportional to the square root of temperature. Okay, but it is inversely proportional to square root molar mass of gas. So kira bila molar mass of the gas is high ataupun big, RMS speed will be lower. Okay, and this one samalah sebab dia directly proportional. So the RMS speed of a gas molecule will increase with increasing temperature. Yalah, sebab dia directly proportional. So if the temperature increase, RMS speed will increase. At a given temperature though, lighter molecules will move faster than the heavier molecules. Okay, so this is valid only for a given set of temperature. Okay, not for all temperatures. So on average, the nitrogen molecules in the air would be moving faster than the oxygen molecules. Okay, hydrogen molecules adalah the fastest of all sebab dia paling ringan. Okay, so this table is just telling you some of the RMS speed for various gases lah. Okay, alright, so now let's look into example number 1. This is where you are gonna apply the formula lah. So there are 8 gas molecules. So there are 8 molecules and then they are moving at random. So each are moving at this speed lah. So we have to determine the mean speed of the molecules. So we know that the formula is V equal to basically this one. I feel like it's easier for you to write this. Okay, so this will be, you have to square them. Yeah, but you have to square them. I forgot mana tu formula dia. VRMS equal to the mean square speed. Dia minta the mean square speed je. So the mean square speed is just this one lah, average, and then kita square dia. So that is 1 square, 2 square, 3 square plus 4 square plus 5 square. Okay, so divide this with the number of molecules, which is 8. Miring juga ni, apa boleh buat lah. That is so bad. What the? Sabar. Buruk betul ba? I mean, you can skip it in YouTube, so it's not really a problem. Okay, so kamu akan dapat the mean square speed to be equal to 8 meters square per second square. Okay, so this looks something like your experiment hari tu kan, your gradient. Next, we have to calculate the mean speed. Oh, this is B. Oh my god. This is B, y'all. So for the mean speed, that is just dorang punya mean. So 1 tambah 1 tambah 2 tambah 2 tambah 2. Tambah 8 pula. Tambah 3 tambah 4 tambah 5. Then kamu bahagi 8. So this is the mean, the average of the speed. So that is just 2.5 meter per second lah. Okay. Kalau enggak tadi tu kita just square dia. Kalau dapat lepas kira yang di bukan pula, silap. Sorry. So iya bah, tidak square. Okay, so itu mean speed. Ini mean speed. Mean maksudnya dia punya average speed. Lepas tu dia suruh kita mean square speed. So ini adalah mean square speed. And then the root mean square speed is RMS lah. So that is square root this. Okay. So kamu akan dapat 8, which is 2.83 meter per second. Alright, so that is the root mean square speed of the molecules. Okay, so basically the trick in this question is apa maksud each of this. Okay, so kamu perlu tahu lah, mean tu firstly it is average. So sekarang ni dia minta average speed. So kamu kira lah average dia berapa. Lepas tu dia tanya lagi average square speed. So maksudnya kita perlu square each of the molecule punya speed. Baru bahagi 8. Baru average dia. So dapatlah dia punya mean square speed. Lepas tu dia minta RMS speed. Barulah kita boleh guna this formula here. Right? Okay, so that is on example 1. Example 2 pula. We have a cylinder with volume 0.08 cubic meter. So the volume is 0.08 cubic meter. It contains oxygen gas and then at a temperature of 280 Kelvin. So you don't have to convert dia sebab dia sudah in Kelvin. Lepas tu dia bagi kita pressure. Pressure is 90 kilopascal. Determine the mass of oxygen in the cylinder. So sekarang ni dia bagi kita sudah the constant punya value lah. Okay. So apa yang kita boleh guna untuk this, kita akan apply the ideal gas law punya equation. Ideal gas equation which is PV equal to nRT. They minta mass of oxygen. So we know that the N here relates to mass of the gas over the molar mass of the gas, number of molecules over the Avogadro's constant. Okay, so sekarang ni kita perlu apply lah this equation so that we can find the mass of the oxygen gas. So kita akan guna yang ini. So bila kita substitute into the equation, it will be mass of the gas over the molar mass of the RT. Okay, so sekarang ni we have to find M lah, the small letter M, the mass of the gas. So if you want to put M, O pun tiada masalah, just to tell you that is the mass of the oxygen, but it's not really needed here because there's only one gas yang we are talking about. Okay, so sekarang ni kita rearrange to get for M lah. So bila kita do it for mass of the gas, this is gonna be PVM over RT. Okay, so sepatutnya if my if I rearrange it correctly, you should get, let me just double check. Okay, I'm just gonna calculate it. Molar mass is 32, but it needs to be in kilograms, so that is 0.123 0.032 over 8.31 times dengan the temperature, which is 280. So dapat 0.099 if I put engineering mode. We do 9.9 lah. Okay, so 9.9 times 10 to the power of negative 2 kilogram. Okay, so make sure this one is converted into kilogram per mole. Okay, so jangan lupa yang itu because I think I almost did. Okay, so that is on the question A lah. Question B pula, we have to calculate the number of oxygen molecules in the cylinder. So number of oxygen molecules, again, we can apply this formula here. Since we already have M and capital M, we can use these two equations here. So that is capital M and over Avogadro's constant. So we need the number of molecules. So rearrange for number of molecules. This is NaM over capital M. Okay, so that is 6.02 times 10 to the power of 23. Is it? Yeah, 23. Times with the mass of the oxygen just now, which is 9.9, over the molar mass of the gas, which is 32. So 0.032. Okay, so the number of molecules is equal to 1.86 times 10 to the power of 24 molecules. Okay, so that is for question B. So if you get an answer macam tiba-tiba sini 1.88, 1.9, okay, it's not wrong, okay? Sebab dalam PSPM kamu ada a range of answers that is acceptable, okay? Tapi kalau based on apa yang dorang kira tu memang begitu, maksudnya kamu yang buat salah lah. Okay? Tapi basically in exam, just make sure you have 3 decimal points lah. So 4 significant figures, final answer tu mesti 3 significant figures lah. Tapi dalam your calculation yang substitution untuk baru je dapat the final answer, make sure to use 3 decimal points. Okay? Okay, next question. Question C. The root mean square speed of the oxygen molecules in the cylinder. So that is just RMS speed. RMS speed is equal to, so we have 3 kT over M. We also have 3 RT over the molar mass. And then what else? What RMS speed punya equation lagi kita ada? Those two je lah yang kita boleh apply for this question. Okay, so these two are the equations that you can use to find the root mean square speed of the oxygen molecules lah. So you can either use this ataupun this. So either one will give you the same answer lah. Tapi kalau macam tiba-tiba kamu punya M ni kamu tidak sure betul atau tidak, kamu boleh je yang guna yang ni sebab the molar mass is given, R is also a constant number. So kamu just substitute lah dalam this equation here. So 3, 8.31, 280, and then we have M is equal to 0.032. Okay, so square root dia, kamu akan dapat the RMS speed to be equal to 467 meter per second. Okay, so this is not a car, okay, this is a molecule, the oxygen molecules. So mestilah dia bergerak dengan laju. Alright, so that is on example 2, and basically that is all for subtopic number 1.